class, and welcome to our simulations project. This is a collaboration between myself, Graham Smith, Areeb, and Rahim. Today we are going to be going through three PHET simulations: the masses and springs simulation, resistance in a wire simulation, and the pendulum lab. So we're going to start with the masses and springs one. So by adding different weight to different springs, we can see there's a different distance. So the length of the spring varies directly to the mass of the weight. We recorded this by using the measuring tool seen here, using these settings here with medium friction and medium softness on the spring. By using those numbers, we were able to generate our equation seen here, which this one is the exact same as the one that we generated in our actual lab. As you can see here, we graphed it, and that graph is exactly the same as the one that we generated here, although it's slightly less curved on this one because the graph is more spaced out. The equations were in fact the same. As for the resistance on a wire one, here we are studying the variation between the amount of resistance of the wire based on the length of the wire. So we notice that as the length of the wire increases, so does the resistance of the wire. So it's a direct variation as well. And what we got for our computer generated model is quite similar to what we got for our handwritten one, although it's a little bit more accurate, but you're going to expect that with a computer. And you can see here it's graphed. You can see we graphed it here. Very similar, although one is spaced out more and one is also on notebook paper, so it's not going to be as neat, although we did use a ruler, so it should be close. And then the last ones are pendulum lab. So what we used is the photogate timer to compare how at the same mass of the weight, how pendulums like the length of time it will take from it to get from point A to point B varies with the length of the wire that the pendulum is hanging from. So when we time the one, we will get approximately 2.8 seconds. And then from the same location, when we time 2, we'll get 2.4. So by using that data, we are able to calculate our computer model here, which was similar to our corrected model that we did by handwriting, although our first one was incorrect. It is a direct variation, and our creative project, we built a life-sized pendulum that actually, if you connected it to some other pieces, would function as a trebuchet, which was used in medieval warfare. And we have that to show today, as well as our PowerPoint. Thank you very much for tuning in, and we hope you check out these simulations for yourself and see what other cool mathematical models you can come up with.